Okay, can everybody hear me? I was afraid I'd have to introduce myself there for a minute, so I'm glad Janine took the microphone back. I'm going to, and I also have the onus here of setting a precedent. I know we each have 8 minutes, so I have to demonstrate it can be done. So I'm going to talk very quickly here. What I wanted to do is just give a general overview of trends and some of the issues we're facing with microgrids. This just shows something I mentioned in the introductory presentation. This phenomenon has been growing significantly. Now, this is based on Navigant data, but it shows that essentially we're growing in North America. The rate of microgrid capacity is growing at nearly 40% a year. That means it's doubling every 2 years. It's a phenomenal rate of growth, and it's been going on for at least the last several years. And the interesting thing, too, is, as I mentioned in my introduction, there was a perception maybe 10 years ago, maybe even 5 years ago, that this was a special application, special for something like military applications that would be willing to pay a lot extra for resiliency because it was so important to them. But as you can see in this pie chart, it's really branched out. And we see a much greater interest among commercial industrial establishments, among campus facilities like universities or data centers or research facilities or hospitals, municipals, and utilities. Now, utilities was not even a part of this pie chart just a few years ago. And they're at 12% here. This was as of mid-2016. I just read an article the other day that they're up to 18%. So the growth has been exponential among utilities. As you can see in this chart, they've grown. Now, this includes not just projects that utilities are leading, but projects that utilities are partnering in. And you can see it went from low single digits just a few years ago to something of the order of the 20 or 30% range, and it continues to grow. So utilities have definitely gotten into the microgrid growth wave. And there are benefits for utilities. Clearly, microgrids improve system reliability. They're a new source of ancillary services. They reduce the need for traditional capital infrastructure investment. It allows utilities a new venue for incorporating intermittent resources, and it's a new revenue stream when utilities take the lead. There's also benefits of utility involvement, though, and that's there's a lot of legal and regulatory uncertainty concerning franchise rights and concerning rights of way. And when the utility is a partner, those pretty much go by the wayside. Utilities can also take a holistic perspective with microgrids, what their optimal size is, what their optimal location is. It can avoid unnecessary expenditures on things like duplicate wires, and utilities have the existing knowledge to make the best use of microgrid applications, both in the design and the operation. And these are just 4 general areas in partnering: the interconnection, the design of the system, the financing of the system, and the management of the microgrid itself. I wanted to, and I'm going to go through these very quickly, but these are, and many thanks. I'll give a shout out to Elisa Wood of Microgrid Knowledge. Many of you are probably a subscriber, and if you're not, you should be, to her excellent publication. And Elisa was a source of many, if not all, of these examples. I just wanted to show the first one, and there was just an article on this recently, that now that the importance of resiliency against storms has gone to the forefront, Alaska has actually been an early prototype of microgrids that were built specifically for resiliency against bad weather. And this is just one example, St. Paul Island, that was constructed using wind and diesel, combined heat and power. And it's done an excellent job. It's got 99% plus reliability in spite of the persistent inclement weather events that occur in that area. This is one, the Peña Station, that was done by Xcel Energy, and this is Xcel is actually doing a battery storage demonstration project, and they built a microgrid around it. It's an excellent prototype because what you see is the core business, in this case Panasonic. It plans on expanding to a much larger facility that's going to accommodate the airport, the entire city of Denver, or much of the city of Denver. And even when it's not serving the resiliency function during outages, it's providing power and helping in reduction of load during peak power times, which I'll talk about in a moment. This is a microgrid in Potsdam, New York. National Grid is doing this project, And this is an example of a multi-stakeholder project. It's interesting to us because it shows the kinds of revenue streams that utilities can get. In addition to traditional rate recovery, there are additional added services that utilities are providing, both as being kind of a middle person for distributed energy, buying those services from distributed energy and selling them into the microgrid, and providing other services like building and underground wiring. This is the Marine Corps Air Station in Yuma, done by Arizona Public Service. Right now it's powered by diesel, but it's, as many of these microgrid projects, it's specifically designed to be able to incorporate storage and renewables in the future. And it's one of two projects, actually. They've also done a project with the data center. And in both cases, they've been able to utilize the grid even when there's not an outage. The grid is providing services, the microgrid is providing services to the rest of the grid. Finally, Green Mountain Power has done a couple of projects. The interesting thing about both of these is that they have actually, an argument frequently against microgrids is that it's a gold-plated way of getting resiliency. Well, these two projects have actually saved money for customers. This one was Stafford Hills in Vermont, solars plus storage, solar panels with the battery. It's actually resulted in cost savings for the customers. This one was actually built for and serves low-income customers and has managed to reduce their bills in many applications. So two excellent cost savings approaches. Of course, the big question these days is how are microgrids holding up, or how will they hold up under adverse weather conditions? Well, we've had a great laboratory this year. We've had not two, not one, not two, not three, but 4 major hurricanes in the area. These just show some of the microgrid applications, mainly in the islands. There was one island in particular there, St. Croix, that got hit by 3 hurricanes, and yet there was a microgrid there, like the Energizer Rabbit, that was still ticking all the way through all 3 of them and providing power. I also mentioned here Arizona Public Service. There was a heat wave, if you recall, last June where the planes couldn't even take off. It was so hot. The Arizona Public Service microgrid actually reduced peak demand during that critical peak period by providing power into the grid. Or I should say it was adding power to serve the peak load. So here's some issues. I wanted to just mention in passing before I close what some of the issues are that utilities have to contend with microgrids. And I can speak from personal experience. I was involved in a filing that Pico Energy did, Philadelphia Electric, last year. And they actually withdrew the filing, and they're going to do it again. But it was kind of a great kind of test experience for them to see what it is that not only their customers, but other third parties wanted to see from utilities. And here are some things that I think all utilities should take to heart as they think about microgrids, is that it should be a stakeholder-involved process. From the design phase on, is that anybody who's affected by this microgrid directly should be involved in the planning and execution process from the beginning. There was a question about distributed energy resources. Now, of course, we believe utilities should be allowed to do that. They should be allowed to provide distributed energy resources, but it's a fair thing to say that it should be a level playing field. And anybody who can do it as cost effectively as utilities should be allowed to do it. Cost recovery is a huge issue. Now, what a lot of utilities have done traditionally with the microgrid projects in the past few years is they've rate-based them. It's the simple solution. It means just essentially spreading it to all the customers. The 2 rationales for that: one is because it's a pilot project, so it's a learning curve, so everybody benefits. The second advantage often touted is that, well, this particular microgrid is serving critical care facilities like police stations, first responders, hospitals, fire stations, and things like that. So it's benefiting the entire grid. That's not an unsound argument, but it's getting harder and harder to make that argument to defend rate-basing the entire microgrid. I think what's going to happen in the future is that regulators will say, okay, well, we acknowledge that X percent, maybe 30 or 40%, is serving the entire grid because of ancillary services, because of providing power during peak times, because you've got first responders inside the grid. But there's a certain percentage, probably the majority, that's going to have to be recovered directly from the microgrid customers. That's the fair way to do it. One complaint against microgrids in general is that it's gold plating. I mentioned this before. is that it's an expensive way to get reliability. I think as cost studies, cost-benefit studies continue to improve, you'll see that the other services provided by microgrids more than justify the cost. Ancillary service provision, and also the ability to arbitrage, to be able to provide power when it's economical to do so compared to other resources in the grid. And finally, utilities should be mindful of the fact too, as all microgrid owners and designers should be, is that there are a number of sources out there for financing, and they should all be explored, particularly grants. There are a lot of states that are providing grants and prizes and such, particularly New York comes to mind. And those are prizes and sources of money that should be taken advantage of when we're doing this, particularly in the early phases. So it's a balancing act between benefits and earnings. Obviously, whoever it is who builds a microgrid has to see a return on their investment. But to make it work, there have to be tangible benefits to those who are on the microgrid. And I think what we've seen in recent years is, as I show here, I think the seesaw is increasingly leaning to the benefit side. And I think the microgrid case is getting easier and easier to make as we become better at building microgrid controllers and technologies, and as we develop a wealth of experience actually doing this in a number of applications. And that's it for me.